Hello, I'm a Mac.
And I'm a PC.
We're both computers. We both have CPU, memory, and input-output. So what makes us different?
Well, there are a few things that make us different. But today, we're just going to talk about one of them. We run different operating systems. So, why do Macs and PCs need different operating systems? What do operating systems do, and how do they differ from each other? The truth is, computers don't actually need operating systems. Originally, programs ran directly on the computer's hardware. Even today, software for things like your microwave will directly access the hardware that it controls. But programming hardware directly has its limitations. What if we want to run more than one program at once? Or what if one of our programs has a bug? Operating systems provide a layer of abstraction between our computer's hardware and our application software. So instead of writing software that directly manipulates our computer's hardware, we write software that interacts with our operating system's APIs instead. This provides a ton of benefits, but today we're just going to focus on the three that we believe are the most important: making software portable, running more than one program on the same piece of hardware at once, and process isolation. I've written a new music streaming application that runs directly on my computer's hardware.
Hey, that's really cool. Can I get a copy?
No, unfortunately, your computer has different hardware. So in order for Evan to run my music streaming application, we're going to have to rewrite the whole thing. There has to be a better way.
If Jessica's application used an operating system, it would use the operating system's hardware interfaces instead of directly communicating with the I/O devices. The operating system then provides drivers so that the same program can work with many different types of devices. For each kind of device, the operating system provides an abstraction which removes unimportant details. For example, instead of talking directly to disks, we use files, which are sort of like magical, infinitely resized disks. Instead of sending raw packets to the network, we use sockets, which provide a stream of bytes. Both of these are much simpler and easy to use. Once the application uses the operating system's hardware interfaces, and I install that operating system, I can now run Jessica's app, no matter what kind of hardware I have. I've been working on my own animation app, and I'd like to use the music from Jessica's. It would be great if I could just run the two programs at the same time, but unfortunately, to do that, we're going to have to combine the two programs into one.
There has to be a better way! Operating systems don't actually run more than one program at the same time. Instead, they offer the illusion of multitasking. To do this, the operating system periodically interrupts the program that's running. The current state of the process, which is the data that's currently stored in the CPU registers, is then saved into memory. The operating system can then load the state of another process into the CPU and let that continue executing. This is called a context switch. So to play music and show an animation at the same time, it switches between the two applications tens or hundreds of times a second. Again, to the programmer, it looks like we're writing one program that controls the entire computer. The operating system is what allows multiple programs to share the hardware.
Great, so now I can run the two programs on my computer at the same time. Except my program has some kind of bug, and every time it crashes, the entire computer locks up and I have to restart the whole thing.
There has to be a better way!
Now that we're running multiple programs, it is much more likely that we're going to hit a bug, and it's also way more expensive if we have to restart because it affects more things. Operating systems provide process isolation to keep programs separate from each other and from the system itself. This way, if a bug happens in a program, it should only affect that one program. This contains the problem and makes systems more reliable. The mechanism I think is the most important is memory protection. The operating system and all the programs running on it share the same physical memory. So if I'm running a web browser and a text editor, and I hit a bug in the web browser, it could scribble on top of the memory that belongs to the text editor, causing it to fail as well as other parts of the system. Instead, the operating system tells the CPU what parts of memory each program is allowed to access. Now, in my web browser, when I hit that bug, the CPU stops it, tells the operating system, which can then kill the web browser and report the problem back to the end user. This is the mechanism that allows your web browser to only stop one tab when it hits a particular problem, instead of crashing the whole browser. It runs each tab in its own process, so that the bug is then contained. So PC, what have we learned today?
We learned how operating systems allow us to write portable software, run more than one program at once on the same piece of hardware, and protect ourselves from bugs.
And all modern operating systems provide these features.
So even though Mac and PC might look different, deep down, we're all pretty pretty much the same.
Well, there has to be a better way.
Ah! I was super weird in that one.
Were you?
I don't know what I was doing.